Hello and welcome to this video on solving quadratics by factoring. Please hit that thumbs up button if you find this lesson helpful. Subscribe to the channel for more math content and drop a comment or question below to engage. If there's something I covered that you'd like to know more of or something that you thought was particularly clear, please let me know. And check out all of the factoring videos on the channel. We have tons of playlists and quite a few videos on factoring, including different methods and using algebra tiles and all that. So what should we know about this strategy? We're going back to quadratic equations at this point. So that means instead of just an expression, we have something with an equal sign in it. And we're interested in solving these equations by using factoring as a strategy. So we're looking for the value of the variable that will make the equation true. Now, this is generally what I would call the preferred strategy. It's preferred over the quadratic formula because it's cleaner. And if you need to go back and get a refresher on the quadratic formula, please go check out that video. It's in the Algebra 1 playlist and in the Quadratics playlist. So how do you use the quadratic formula? But typically, when you're factoring, it doesn't involve as many steps or as many lines. It just looks cleaner. So you might ask yourself, well, if it's the preferred strategy, why don't we just use it all the time if it's like so great? Well, because not all quadratics can be solved this way. So a quadratic is factorable if the discriminant is a perfect square, and that includes the number 0. Now, again, there's a video on the channel for the discriminant. So if you're thinking, what is she doing? I don't know what she's doing here. Go back and check out that video. So the discriminant is the part of the quadratic formula that is b squared minus 4ac. And I'm going to put two quadratics up here just as an example. So 2x squared plus 3x minus 1. Now that is a quadratic expression, which we could factor. To make this a quadratic equation, I have to add an equal something. I'm going to add an equal 0. And then we'll have this one right here, 2x squared minus x minus 1 equals 0. And the discriminant is the b squared minus 4ac. So looking at this first one, my a value is 2, and my b value is 3, and my c value is -1. So when I go to plug that into the discriminant, I'm going to do 3 squared minus 4 times 2 times -1. Might be helpful here instead of a minus to do plus a negative right there. 3 squared is 9, and then -4 times 2 is -8. And -8 times -1 is +8. And I get 9 plus 8, and I get 17. 17 is not a perfect square, so this is actually not factorable. If you set up your area model or you did your slide divide, whatever you were doing, you would not be able to find the numbers that work. So you'd list out all of your possible factor pairs, and none of them would actually work. And that's because this is not factorable. Now this one here, though, I've got a is equal to 2, b is equal to -1, and c is equal to -1. So for this one, if I plug this in, we have b squared minus 4 times 2 times -1. I'm going to do the same thing. I'm going to change that minus to plus negative. 1 squared or -1 squared is 1, and then -4 times 2 is -8, and -8 times -1 is +8, and then 1 plus 8 is 9, and that is a perfect square, so this one is factorable, which means that if you set up your area model or whatever strategy you're using, the numbers will exist to be able to put into it to make it work. And so not all quadratics can be solved using factoring as a strategy. So that's why we need the quadratic formula and other strategies for solving quadratics. But if a quadratic is factorable, it is generally the preferred strategy to use. Now, this is where you want to listen up in your classroom. Most of the time, if a teacher asks you to solve a quadratic by factoring, it will be factorable. Now, that's not foolproof. And again, there might be differences in directions. So if the directions just say solve the quadratic, and it does not specify a strategy, then that's completely up in the air whether or not factoring will work. And it would be up to you to figure out which strategy you wanted to use or which was best. But a lot of times, I would say most of the time, if the directions specifically say to use factoring, then factoring will be a doable strategy for you. Okay, so the key idea, the grounding idea behind using factoring to solve quadratics is something called the zero product property. And you can think about what these words mean. Zero refers to the number zero. Product refers to the result of multiplication. And then a property is just a rule or some general property principle that we can use, okay, in math. So this has something to do with zeros and multiplying. Here's what the zero product property is. If A times B, and by A times B, I just mean two things, two anythings, okay? They could be numbers, they could be variables, they could be variable expressions, two things that multiply together, and the product is zero, then the first factor is equal to zero, or the second factor is equal to zero, or both. Okay, now just to reason that out, okay, because we don't want to just be throwing properties out there willy-nilly. If you have two things multiplied together and you want the product to be zero, well, what if both of them were positive? Okay, if both of them were positive, then the product would be positive. A positive times a positive is a positive. If both of them were negative, the product would be positive. If you had one of each, okay, and you could put that either order, all right, doesn't matter. If you have one of each, the product would be negative. The only way for you to get a product of zero is for one of those numbers to be a zero. A positive number times zero would give you zero, or a negative number times zero could give you zero, or zero times zero could give you zero. Could be both of them. But the only way for you to get a zero as the product right here, if I can find my mouse, maybe I will not be able to find my mouse. There it is. The only way for you to get a product of zero right here is for one of those things to be equal to zero. So how does that pertain to quadratics? Suppose you have x minus 1 times x plus 2. And what you want to remember here is that that is a product, okay? That is a factor of x minus 1 times a factor of x plus 2. And the product of those factors is 0. What that means is that either that first factor had to be 0, so the x minus 1 had to be 0, or the x plus 2 had to be equal to 0. And then we could solve this by adding 1 to both sides. So x could be equal to 1, or we could subtract 2 and get x is equal to negative 2. And if you go back and plug those in, okay, so remember what it is to check your work. If I take x is equal to 1 and plug it in, I would have 1 minus 1, and this would be 1 plus 2. 1 minus 1 is 0, 1 plus 2 is 3, and I get a true statement. I get 0 equals 0. But it will also work if x is equal to negative 2. So if I have negative 2 minus 1 and negative 2 plus 2, this would be negative 3 times 0. And once again, we get 0 equals to 0. So that equation has two solutions. Both of them work, meaning both of them, you could plug them back in and you get a true statement. And when you're solving the quadratic, you need to get all of the possible solutions. But that's essentially how the zero product property works. Now, to solve a quadratic equation by factoring, this is what we do. We set the equation equal to 0. Meaning we have to get that 0 in there. If we do not have a 0, none of this works. Okay, there's an infinite number of things that can multiply together to give you a 1. 0 is the only number this works with. Then we factor it. So you'll notice that the equation right here was in factored form. So it had been factored. And then you use the zero product property to find the values of x, meaning you set each factor equal to 0 and then solve each factor as a separate equation. So here we have one. We have x squared plus 4x minus 21 is equal to 0. So we do need to have that 0 there. If you have anything other than a 0, you've got to juggle things around so that you can get a 0. Now, what I'm going to do here in my factoring is I am going to write the factors underneath it, and I'm going to do my factoring scratch work off to the side. So we've got x squared and negative 21. We're going to do 1 times negative 21 to get negative 21. And we're looking for two factors that add up to positive 4, and I have them right there. If the 3 is negative and the 7 is positive, then I will have the 4. Negative 3 times 7 is negative 21. Negative 3 plus 7 is positive 4. So we have negative 3x and 7x. Doing our GCF factoring, greatest common factor there is x. X times x is x squared. We've got a negative 3 and a 7. And instead of writing my factors down below here, I'm going to go over here and write the factors in. So I have a factor of x minus 3 and a factor of x plus 7. And now that zero product property kicks in. Okay, I got two things right there being multiplied together. So x minus 3 could be equal to 0, or x plus 7 could be equal to 0. And you can do like plus 3 and say x is equal to 3, but generally we won't. All right, and so here I could do minus 7, but I'm just going to go ahead and say x is equal to negative 7. And there are the two answers. And you could go back to your original equation. So we had the x squared plus 4x minus 21, and I'm going to use the 3 because it's simpler. So 3 squared plus 4 times 3 minus 21. 3 squared is 9 plus 12 minus 21. 9 plus 12 is 21. And oh, look at that. 0 equals 0. And you can plug in the negative 7 and do the negative 7 as well, but I promise you it will work. So that will also work. And what we've done is we've solved the quadratic equation. All right, now this second example is one where it's not set equal to 0, and I am going to address the different ways that you might get this equal to 0. But for now, what I would do, okay, if I'm doing this problem on my own, is my next line is going to be 3x squared plus 2x minus 8 equals 0. And I've been doing this for a really, really long time. So in my head, what I'm saying is I'm going to move that 8 and that 2x over to the other side. I'm going to do that by adding 2x to both sides, and I'm going to subtract 8 from both sides. Now, if you are not comfortable with that, this is what the middle piece of that would look like. You would add 2x to both sides. So that's going to give you 3x squared plus 2x equals 8. And then you would subtract the 8 from both sides. If you're comfortable just like bouncing there, like, okay, I'm going to add, subtract from both sides, go for it. Okay, you do not have to keep doing this out. We do want to check for a GCF, but 3 and 2 are prime numbers and they don't, they're prime. So nope. And I'm going to go ahead and write my factors underneath and then use this space over here for my scratch work. So I have 3x squared and negative 8. 3 times negative 8 is negative 24. And I want two factors of negative 24 that will add up to that positive 2. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. There it is. If the 4 is negative and the 6 is positive, we'll do a quick double check. Negative 4 times positive 6 gives me negative 24. Negative 4 plus 6 is positive 2. So I'm confident I have that right. So this is negative 4x and 6x. GCF going from right to left or left to right here would be x. And then 3x times x gives me the 3x squared. Negative 4 times x gives me negative 4x. And 3x times 2 would give me the 6x. And then 2 times negative 4 does give me the negative 8. And instead of writing my factors below, I'm going to come over here and write them. So 3x minus 4 and x plus 2. Now I'm going to kick in that zero product property. I have two things multiplied together and the product is 0. So it could be the 3x minus 4. Or it could be the x plus 2. If you want to jump right to, therefore, x is minus 2, go for it, okay? Now, the work there that I'm not showing is minus 2, minus 2. Over here on the left, you might need to do a little bit more work. We're going to add 4 to both sides to get 3x is equal to 4, and then divide both sides by 3, and we get x is equal to 4. There we go. Yay. All right, moving on. All right, how much work is required? Now, little disclaimer here, how much work is required is whatever your teacher is requiring you to show. So we live in an era where you could take a photograph of this problem and the interwebs is going to give you an answer. The interwebs is probably going to give you like all the work too. So I like don't, okay, just don't. Do it out, use that to check your work. But your teacher might require you to show your work a particular way. So here's what I would typically show for work. Okay, this is like what I, as somebody who's done this for a long time, would do. I would move the 6 over to the other side by subtracting, but I would not show that I was subtracting 6 from both sides. Like this is just a given. Now, I've factored a long time, and if you watched my video on comparisons of ways to factor, I did mention at the end of that video, I was taught by trial and error. And so I don't typically set up the area model unless I feel like I am getting stuck on something. So I would fill it in with 5x and x because 5 is a prime number. And then in my head, okay, I am in my head going to play around with the factors of 6 to see if I can find something that will give me that 13. If I use a 6 and a 1, I'm going to end up with 5s and 6s, or maybe a 30 if I put the 6 over there. That's not right. So I'm pretty sure it's a 2 and a 3. 5 times 3 on that like outer piece would give me 15, which would get me very close to the 13. And then if I do a minus 2, 15, literally what I'm doing in my head is I'm doing 15x minus 2x. 15x minus 2x is 13x. I'm not showing the area model for that. Now I would go straight to x is equal to -3. Right there, I would skip over x plus 3 equals 0. And I know that if x plus 3 is a factor, then that's going to dump out as x is equal to -3. And I would also do this one in my head as well and say x is equal to 2/5. Again, I've been doing this for more than 30 years. Like it's been a while. Now what you might show, so here are the optional pieces, is you might show x plus 3 equals 0 and then go to x equals -3, or you might go as far as actually writing in the x minus 3, x minus 3 minus 3. Over here, okay, and your teacher might very likely require that. And then you would have the adding of the 2 to both sides. So you do plus 2, and then you would divide by 5. Again, I've done so many of these for so long that doing that in my head is not an issue. So follow your teacher's directions, okay, with how much you need to show, and do that before you get to a test. So bring your homework, bring your classwork up to the teacher and say, am I showing enough work? Okay, is there something that you're not seeing that you would like to see? If your teacher wants to see your scratch work for the factorization process, okay, you would do that off to the side and go up, come up with all your factor pairs. And what do we look? Ooh, this is one of the ones that has more than one possible combination. We want this one, I believe. I think we want a -2 and a +15. Yeah, is what we want. So follow what your teacher's directions say for you to do. But this is what I would do as you move further on in math, especially once everyone is confident that we know how to factor. We can show less work there. Okay, so a few tips. Do not try to factor with a -a value. So this goes back to one of the problems that I did earlier where I added the 2x and subtracted the 8 from both sides. So I did 3x squared plus 2x minus 8 is equal to 0. And you might be wondering, well, why didn't you do this? Why didn't you just subtract the 3x squared? And then you'd have a 0 equals -3x squared. I guess it would be, I'm gonna make sure we get this in the right order. Minus 2x plus 8, we're gonna switch the order there. If you're doing the quadratic formula, it does not matter. And I have a little short video that I made that shows why this would give you the same answers, and it would give you the same answers. But if you've got that -3 out front, where you end up placing that negative in terms of your factors does get very messy. So strongly discourage you from factoring with a negative a value. Okay, just whichever direction you have to move the terms to make sure that number is positive, that's what you should do. If you can't factor it quickly, check the discriminant to make sure it is factorable, especially if your teacher has not told you that they are factorable. Okay, so if there's a possibility that the quadratic is not factorable, you don't want to waste 15 minutes trying to come up with factors that don't exist. And then review factoring when needed. What I'm going to do is link a card right up here, okay, for the practice video on factoring. So if you just need to factor a whole bunch and get your factoring skills shored up, go click that link and see what that's about. Okay. So like this video, I'm sorry, don't forget to like this video if you found it helpful, subscribe for more math help, drop a comment or question below to engage, check out the practice set for this lesson and the other videos on the channel. And I am going to not do this in the card above. I'm going to do this in the link below. It'll be like over here somewhere. And the practice set is in the description box. So go ahead and click on that for some practice on this lesson. Hope you found it helpful, and I hope to see you in the next video.